Hi, welcome to my channel. Today we'll discuss the Benford's law. What is Benford's law? As you can see on the screen, Benford's law, also known as the Newcomb-Benford's law, is an observation about the leading digits of the numbers found in real-world datasets. It is also known as the first digit law. It is a statistical principle that states that in most of the real-world datasets, the leading digit, which is the leftmost non-zero digit, is likely to be a small number. So, the leading digits in a naturally occurring real world and Benford compliant dataset, the smaller leading digits like 1, 2, 3 are more frequent than the higher digits like 7, 8, or 9. And the leading digits follow a precise and consistent pattern. As you can see on the right, this is called as the Benford's distribution. This graph displays the logarithmic distribution of leading digits according to Benford's law. As you can see, the probability of number 1 as being a leading digit occurs 30.1% of the time, and the probability of digit 2 occurs 17.6% of the time, and so on. Now, typically in larger datasets, like for example, if you have a sales dataset or a financial dataset, those kind of datasets, the datasets will produce observed relative frequencies that more likely approximate the theoretical values of Benford's law, right? So that what do we mean by that? Say, for example, if you have a sales data set, and data set, as we all know, every day the sales varies, right? Those numbers will vary. And say, for example, if you have $100 sale in a day, and the next day there is 300, another day it is 1,000, or another day it's $50. So those numbers keep varying, right? And also some days you might get $1,000 sale, $10,000 if the store, or if the company is a large enough company, it goes into millions too, right? So that means we have multiple orders of magnitude. So these are the data sets where you could probably apply to test the theory, Benford's law, whether they kind of obey the theory or not. However, there are certain limitations, as Benford's law does not apply to every set of numbers. Now, here you can see that, as we've already said, that bank statements and financial data, sales data, those kind of data sets we can conveniently work on whether it obeys Benford's law or not, right? However, if the numbers are kind of pre-assigned, right? Say instead of naturally occurring, like for example, if you have social security numbers or telephone numbers or zip codes, this we cannot test Bedford's theory on those kind of data sets, because there is a threshold, right? There is a min and maximum, there is a lower bound and upper bound. Like for example, GPA or IQ scores, this will not work. So to reiterate, the data set should be naturally occurring, and it should have multiple orders of magnitude, and preferably the data should have at least 200 observations. There are cases where a lot of people have done with a smaller data set, but 200, 500,000, those kind of observations will give you better results. So now, the reason why uh, Benford's law is coming into prominence for the past several decades is that, suppose we have a data set, right? Like we discussed, a financial data set or something. Now, if somebody is trying to fudge those numbers, right, intentionally they're trying to fabricate, then the distribution will definitely look different. That is what most of the auditors over a period of time, statisticians who worked on Benford's law and tried to apply that theory on several datasets, they found out that whenever somebody is trying to change those numbers intentionally, and the numbers, those distributions would not obey the expected Benford's distribution. So, basically this is kind of a helpful tool for all those auditors, right? So again, we have to keep an important note in mind that this will definitely will not prove or disprove anything, right, one way or the other, if there is a fraud involved in that particular data set or not. But again, as we said, this will be a helpful tool, right? You can do objective investigation while doing your audit. And also uh, most of the places, right? Most of the places when data is there, most of the data engineers or data analysts would love to look at the data, try to get insights, right? There are certain cases where, like, if you want to audit the data, right? So those kind of places, those kind of situations, rather, you could definitely use Benford's law, right? To recap, we understand that Benford's law is the first digit law, and the leading digits in most of the real world data sets like population numbers or street addresses or scientific data or sales data, in those type of data sets, the numbers follow a logarithmic distribution, as we see on the right side, right? A leading digit 1, if it is 1, it is 30.1% of the time, and compared to 9, leading digit 1 will be almost like 6 times it will appear. That means lower numbers 1, 2, 3 will appear more frequently compared to numbers like 7, 8, 9, right? So, and again, as you can see on the graph on the right hand side, as the leading digit is 1 through 9, right? On the x-axis, if you see, as the leading digit is increasing, the frequency is decreasing. So that is one way of remembering the Benford's law. There is it is also expressed mathematically as PD equal to common logarithm 1 plus 1 by d, where PD is the probability of a digit appearing as a leading digit, and that is the range of 1 to 9, right? So as we have discussed already, it has to be a non-zero digit, and the digits are 1 through 9. So that is the mathematical expression. And if you need more in-depth details about Benford's law, I suggest you to read up on many articles written by experts. Now that we have understood the basics of the Benford's law, in the next video, we will download a sample dataset from the internet, and using Microsoft Excel, we will try to test this theory on the dataset. Thanks for watching, and see you in the next video.